Hello everyone. So I'm not sure if you know what Codecrafters is. Codecrafters is a platform that lets you do build your own software kind of challenge. And as you can see, I have completed build your own Git, and it was an easy challenge. Only had 7 stages. And lately I had been working on build your own Redis, and I have done about half of it. So I thought I'd make a few videos on it, how I implemented my solution. It also has other build your own web HTTP server, build your own BitTorrent, Kafka, interpreter, grep, shell, SQLite, and DNS server. Let me know if you want me to make videos on any other. Uh, this series is going to be on build your own Redis, and I'll be doing it in Java. So when you buy Codecrafters subscription or membership, uh, you will be able to create new repositories and they'll be managed by Codecrafters. Uh, so here I can retry with Java. This created a new repository for me and preferred language Java, language preference intermediate. Next question, it asks a few questions. I'll pass. Next step. So it gives you steps that you need to do to pass each and every stage that they have, and you just have to implement the solution to those requirements. And so the initial stage is just a repository setup. Uh, so let's do that. I'll open desktop. I have Codecrafters. I'll delete this. It has given me git commands to clone their repo and cd into it. And then it will make me push an empty commit so that they know my repository is initialized and set up so they can listen to it on every push and run their own test suite on my code. As you can see in the logs, they're running tests on my code. So right now the repository is empty and all the test cases should fail. And the first test has failed. And if you go back to the website, it'll show that the stage has completed and I can proceed to the next one. So let me open that folder in IntelliJ. This is okay. Open and this is the code that they provide us. It has one class, main, and everything is commented. If you read the requirements that they provided us, you'll see what they want you to do is open VS Code and go to this file. I have opened it in IntelliJ, and then they want you to uncomment the following code. Okay, obviously not this one. And mark is complete. Now they want you to commit and push to master. Okay, so I'll open the terminal. I'll give each commit the name of the stage. It is JM1. Going forward for each stage, I think I'll be creating a new branch and then merge it into master and then push to origin. Git push. Oh, sorry. Additionally, what I'll do is I'll create my own repo. I'm creating right now on Azure DevOps. You can create on GitHub if you like. I'll share this link with you with the link to my repo with you. You can see my code from there. New repository. It will be Codecrafters Redis Java. So I think I already have that repo. Codecrafters Redis new Java. Okay. I'll share the link to this repo with you in the description or the comments. And if I refresh, I'll see two branches here. One main and one master. So the main branch is what Azure DevOps creates for me by default. I don't want that. I want master because that's what Codecrafters has created for me. And I'll delete the main branch. I don't want it. All my code is a master branch. So as you can see, I'll share this link with you. So when I pushed to origin, git push origin, it said build success and it ran a test and test passed. So if you go to Codecrafters website, you'll see the stage will be completed and I can go ahead to the next stage. So if you are ever stuck, oh, I'll talk about that later in other stages. You can mark it as complete and move on to the next stage. Okay, so in this stage, we need to implement our own solution. Unlike stage 1, this doesn't have commented code. Step 1, implement solution, open IDE. You can use the output to this part. To pass the stage, you'll need to send a Pong response to output stream of a client socket. Okay, and you can use the output stream.write method, which accepts a byte array. So okay, so it has output stream of client socket. Do I have a client socket here? Most probably do. Yeah, they have given me a client socket, and you can use the output stream to. You'll need to send a Pong response to output stream. Okay, so in any case, I need to send this output stream. I can just copy it, I think so. And reuse address, accept. I can import it. This is RG2. This is a very simple code change. I don't feel like creating a new branch for this. So let's see what the code that they gave us actually is. They have a variable server socket and a variable socket. Okay, and they have hard coded a port 6379, which is the Redis port. They've initialized server socket on that port and sets reuse address to true so that when I keep bringing this application up again and again and closing it again and again, it frees the port 6379 when I close the application so that the next time I bring up the application, the port is free to be used again. That's all this line does. And they have okay, client socket, server socket dot accept. They have accepted a socket and saved it into client socket. Now they want us to get an output stream from the client socket and write Pong to it. Now, what is this format? plus pong slash r slash n. So this is the pong string, but the format it's written in, it's a REST serialization protocol. We'll learn more about it as we go ahead. It's the format Redis expects strings to be written in. We'll learn about it later. That's why they have given it like this. And it's all written in a try, in catch, and printing the exception. And finally, we are closing the client socket. That's it. Okay. So if you see the log from a push, it will say test passed. And they received a pong from us, which we wrote to the output stream right here. And they say test passed. And if I go back to the website, it'll show stage passed, and I can move on to the next one. Okay. Now, what a ping or a pong is, I'm assuming you know, because you're trying to build Redis, I'm assuming you know what a ping and pong is. In this stage, you'll implement the support for the ping command for Redis. The Redis client communicates with the Redis server by sending commands, and ping is a Redis command. You can send it to the Redis server using the Redis CLI. Ping is one of the simplest Redis commands. It is used to check whether a Redis server is healthy. The response to ping command is plus pong slash r slash n. Retired nurse slash r slash n. Return garage. And a new line with the return garage. Okay. CRLF. This is the string pong encoded in the Redis protocol. In this stage, we'll cut corners by ignoring client input and hard coding as a response. We'll learn to pass client inputs in later stages. Yeah. You can ignore the data that the exact bytes your program receive won't be just ping. You'll receive something like, okay, so we are receiving a ping. We're just not checking it. We're just sending the pong anyways. A ping is expected. So if I were to get the input stream from the client socket, I'll be seeing this string in that stream. I'll see a byte array, and when I convert that byte array to string, I'll see this string in the input stream. No, we are not parsing it, we are not reading it even. We are just sending a pong anyways because we know we are expecting a ping. Uh-huh. So what the Redis serialization protocol is, JSON is a serialization protocol. When you work on HTTP, you send JSON data from the backend to the front end, from the front end to the backend, and it's a format of writing data. That's it. Keys have value, and the values can be arrays or strings or numbers, like that. Similarly, YAML, yet another markup language, is another serialization protocol. That's it. Redis has its own serialization protocol that we need to implement in this build your, build your own Redis challenge. We'll learn more about this protocol later. We'll go a lot in depth. And in the meantime, let's go ahead to the next stage. I I should let you know this is not a tutorial series. This is just me showing what I did. So I apologize if I'm not the best teacher, but I'm not trying to teach. I'm just showing what I did. So in this stage, we'll respond to the ping commands, and by the same connection, a Redis server starts to listen for the next command as soon as it's done responding to the previous one. This allows Redis clients to send multiple commands using the same connection. That means the client socket isn't expected to be closed, it's expected to be kept open. Okay, so since Redis server is like a daemon of sorts, not demon, uh, daemon, a daemon server of sorts, I'm assuming yeah, I'm not assuming, I know. We'll be doing the reading from the input stream and out writing to the output stream in an infinite loop. And the client socket should only be closed in case of errors or the when we want to quit the server. Only in that case should the client socket be closed. All this will happen in an infinite loop. Here, true. All this reading and writing will happen in an infinite loop. I'll create other classes to handle that later on. I'm not trying to do any whiteboard masturbation right now. No premature optimization. We'll just pass the stages as required. In this stage, you'll respond to the multiple ping commands. Okay, so there will be multiple ping commands sent by we don't know how many. Redis client to send multiple commands using the same connection. They send multiple ping commands. Ping double, okay, send double ping to the Redis CLI. The tester will expect to receive multiple Pong responses, one for each command. So we don't know how many pings there are. We need to count, we need to respond to each and every ping. So in this stage, we'll need to read from the input stream, hard code. We can hard code the Pong as the response sent using the same connection. Okay. So how do we read from the input stream? I don't know. Let's ask AI. How to read from the input stream? Okay, so there is a get input stream method on client socket that I can use to get the input stream. It's giving me a buffered reader. What if I don't need a buffered reader? Can't I use scanner? Okay, we won't use buffered reader or scanner. We'll just get a byte array and convert that to string. That seems the simplest approach. So my client socket was accepted. I got the input stream out of it. Use scanner on the input stream. C dot next line. Let's see what I receive from the let's see what I receive in the input stream first. I'm just printing out the line that I'm getting. What's the delete the is never thrown. Huh? Client socket dot close. Okay, yeah. How can I test that? Oh, so you have the option to use the test runner, Codecrafters test. Instead, what you can do is you can just push to their server and that will run the tests for you. So this is stage WY1. Git push and it will start running the test on my code and I'll see what they're actually sending me. I received a star 1 in the next line. Only star 1. What does that mean? I was expecting this string, but I received a star 1. How can I confirm that? I can confirm that this is kinda like test-driven development. They've already written the tests for us. I'm just abusing them. So yeah, 100% confirmed. I'm just receiving star 1 in the next line. Why is that? So the next line breaks at slash r slash n. So yeah. So what I'm receiving is our ping commands serialized in the Redis protocol. So I need to read everything that is in the scanner. While sc dot has next line, I'll print the next line. Okay, let's abuse the tests again. As you can see, I received a star 1, a $4, and a ping. So what do the star and 1 and the $4 mean? To understand that, we'll need to go to the Redis serialization protocol. In this stage, we're expected to read the ping from the input stream. And if you come down to the comments of this section, they'll tell you what you need to read. Very good people there. Friendly reminder, you still don't need to pass the incoming requests. You can still hard code as the response you'll get to parsing the in stage 5, implementing the echo command. The test seem to be expecting servers to handle case insensitive command keys, but I haven't been able to find anything in spec which suggests that this is correct. This isn't defined in the Redis serialization protocol, but it is mentioned in the command page. Redis command names are case insensitive. So ping, small p, small I, small n, small g are same as capital P, capital I, capital N, capital G. A tester isn't designed to test cases insensitivity specifically. It's just that we use the official Redis Go client to test your implementation, and it uses lowercase commands by default. So what we'll be receiving are lowercase pings, but I received an uppercase ping. Perhaps Redis Go client has changed and it's sending commands now in caps. So what is the Redis serialization protocol say about? I received a star, right? So I'll just search for a star. Okay, so if the first byte is a star, what is expected is an array. An array starts with a star. And then what I received? I received a $4. A dollar is just a string, bulk string. Okay, so what does the 4 mean? The 4 followed by dollar just means that the next string that's going to follow is going to be 4 characters long. And what the 1 after the star means that this is an array of size 1. That's all that it means. So, do I need to, as they say, I don't need to actually parse the input in this stage. You can hard code as the response. We'll get to parsing the incoming requests in stage 5. Okay, so right now, as long as I have a ping, I need to respond with a pong. Okay. String. Next line. If next line dot contains ping uh, output string. Output string dot write, not pong. We have to write it in the Redis serialization protocol format. /r/1 I guess 1/1 yeah, that's it. I'm expecting to pass the stages now. Let's see if anything else is expected from us. So if whenever I'm receiving a ping in my input stream, I'm responding with a pong. See, I was expecting to pass the tests. I have passed the tests. That's all was required in this stage. We'll clean the code later. I'm just going ahead right now. I'll make another video on refactoring the code later because right now it's not very complicated. It's pretty simple code. It's nothing. If I go back to the website, it'll say stage completed. I'll mark it as complete and go ahead. Uh, Now I'm supposed to handle concurrent clients. Okay. In this stage, we'll add support for multiple concurrent clients. In addition to handling multiple commands from the same client, Redis servers are also designed to handle multiple clients at once. To implement this, you'll need to either use threads or, if you're feeling adventurous, an event loop, like the official Redis implementation does. So what an event loop is, have you ever seen any video on game programming or anything like that? So what they have in game programming something called as an event loop, which is an infinite loop. It keeps on running and it keeps on listening for new clients. But not keep on listening. So what an event loop is? We'll go ahead with an event loop. Let's see what an event loop is. So as you can see, an event loop is just an infinite loop. It keeps on reading and keeps on doing stuff. And in our context, what do I need to keep on doing? I need to keep on listening for new clients and respond to their commands. That's all that I need to do. So there will be two clients or multiple clients. And what I'm expected to do is this client socket. Okay. This is what an event loop is. But all this stuff needs to happen in a separate thread so that I don't override the original client. So if I receive the client number one, I need to do everything for that, all these lines that need to run for that as well. And then it needs to run for the next client and then for the next client. So what I'll do is I'll create a new method that will be doing it for me. Public void handle clients and it receives a client socket. What expected? Oh, sorry. will ask me to throw an error. So if you don't know what concurrency is, how can I call that method in another thread? You need to learn what concurrency is, what completable futures are. I'm not going to be teaching you that. I'm expecting you know that because we'll be using that a lot here. Completable future dot run a sync. Acha, it was static method, so my method also needs to be static. It is a client socket and it throws an error. Server socket. Oh, sorry. Client socket. And it throws around with try catch because it throws an error. Now this code will call this handle client method for me in a separate thread. And my separate threads will be responding to these clients. So let's see what I've changed. The server socket is being initialized. The server socket is being told to reuse the address again and again. And then in an infinite loop, I'm listening for new clients. I am creating a new variable, final client socket, that will be passed to my handle client method that's being run in a separate thread by a completable future. So if you come from a JavaScript or a C# background, what you are required to do here is an async await call. That's it. And it seems to be right. Let's see if it passes. We get add, get commit. What's the stage? The stage is ZU2, sorry. Get push. I passed. Okay, pretty simple. I'll mark it as complete. Let's see the comments on this. The best explanation for event loop I've seen is a talk by Philip Robert. Did a YouTube video. You can check that on your own. I have a blog post about Ruby where I first implemented a solution using threads and then changed it to using an event loop. Perhaps my solution is not a good event loop. I'm not adding the clients to a queue. I'm using threads here. I'll check the event loop video and if I see something I can change, I'll make another video on that. But right now I'm going ahead with these threads. Why am I doing that? Because I've done this challenge already in C# and in Java, and in both those cases I used threads. So I'm using threads here as well. Another cool talk on the browser event loop. Okay, so these are the browser event loops. This is JavaScript event loop. I don't want to know about that. Ew, JavaScript. Okay, let's go to the next stage. In this stage, you'll add support for the echo command. Echo is a command like ping that's used for testing and debugging. It accepts a single argument and returns it back as a RESP bulk string. So whatever we receive, we'll send it back to the output stream. Read from the input streamer, right? This is the output stream. So if they echo hey, I have to return hey. So let's see what I actually receive. I'm already printing that. I won't write anything to the output as of it. I'll just print it. Yeah. South. Next line. I'll see what I'm receiving actually first before implementing a solution. What format am I receiving the command in? Write a clean Redis protocol parser. Open source Redis clients are a great place to start. Redis. Haha. Good luck trying to understand this repo. This is a huge repo. It's a big ass repo. It's a chonker repo. Good luck. If you are good at understanding other people's code, I'll tell you to go ahead. This is not something that I want to do for this. I have done this already without going through that repo. If you're using Netcat to test instead of Redis CLI, you can use this format to send proper RESP encoded commands for this stage. Okay, so perhaps I'm receiving something like this. Let's see what I received in the output. I received a star2, which means an array of size 2. The first element is a string of length 4. The second element is a string of length 10 and strawberry. I did not receive a ping. So am I not going to receive a ping in this? Huh. Okay. So if I'm receiving a strawberry, I am supposed to return a strawberry. If I'm receiving a hay, I'm supposed to return a hay. And a hay looks like this, right? Everything is separated by slash r, retired nurse slash r slash n. Why am I calling it retired nurse? Because that's what Primogen calls it. That's the only reason I'm calling it retired nurse. Okay, so string and it's and I'm encoding into resp string and I receive a string. Okay, string resp. So the any string must necessarily start with a dollar. That's what the RESP serialization protocol is. If you need to understand what the REST serialization protocol is, go through this link. Try to understand it. I've gone through it already, so I'm showing you how to implement this stuff. The next thing that needs to be added to RESP is the length of the string s. No. Yeah. After this, there is supposed to be a returners. If you see here, that's what expected between the strings. After that, my string needs to follow. And then I'm supposed to end again with the returners. Carriage return new line. and I'm supposed to return a resp. So if my next line contains echo, if next line contains string, I'm supposed to write pong. If sooner or later I'll convert it to a switch case, that seems to be the better approach. If I received an echo command, so if I check the output, my echo will be followed by a $10 and then strawberry. So the next line after echo will be $10 and the next line after that will be the actual string. So I don't actually even need this method. What I can do is string the rest header is sc.next line and that string the rest body is sc.next line. I think I can concatenate them and write, yeah, output stream dot write resp header plus resp body concatenated dot get bytes. I'm assuming this works. I'm not even using this method right now, but that's how a string would be encoded in resp. Now all this is a very inefficient code. Instead of strings, I should be using a string builder, and instead of a string builder, I should be manipulating the raw bytes that I'm receiving. I'll do that sooner or later, maybe later. Let's see if I pass the stage. If I don't, we'll change it. I'll start reading it byte by byte instead of using a scanner. Huh? Strawberry? $10. Okay. So they received a $10 strawberry and it was not separated by a retired nurse. So I'll concatenate the retired nurse by myself. Excuse me. I think this should pass. Let's see. Perhaps I should be writing unit tests for this. I don't know, not unit tests, integration tests, if anything. Yeah, I should be writing integration tests for it. Okay, I think I'll do that in the next video. I'll write some integration tests for these stages. Okay, so if I received a pong, I responded with a pong. If I received a ping, I responded with a pong. And when I received an echo, I responded with the correct string. I passed the stage. That's all that was required here. Okay, now sooner or later, we will need to do byte by byte because RDB file persistence, I'm not interested in this. I'll do this stage, RDB persistence, later. Why? Because replication is very, very interesting. It's the complete client server architecture that the Redis has, the read replicas and everything. It's very interesting. RDB persistence, it's not that interesting. So I'll be doing replication. After that, stream data type to your Redis implement. It's just another data. Transactions is interesting. After that, stream, and after that, RDB persistence. Perhaps I should be doing RDB persistence first because it's the moat of Redis that it writes to the file system, and then we can recreate the data in case the Redis server goes down. Even though the Redis is in memory, we can recreate the data using the RDB file and the transaction logs that we have. I'll do it later. Replication is very interesting. I'll do replication first. Then perhaps I'll go for RDB persistence. Okay, so I can mark this stage as completed. And now we need to add support for the set and get commands. So what the set and get commands do is it just stores the key and the value into a hash map. And since we are in a concurrent environment, I'll be using a concurrent hash map instead. Okay, so echo is completed, set and get. In this stage, we'll add support for the set and get commands. If you need to know what set and get commands are basically just a hash map dot put and hash map dot get. If you want to explore, you can read the official Redis documentation. I am not interested. The set command is used to set a key to a value. The get command used to retrieve the value of the key. So now I will need to go byte by byte because I don't know how many next lines I need to do. That's the problem with scanner here. We can't go ahead with scanner because I don't know how many next lines. Can I change the default delimiter of scanner? If I can, how about I use a character that is never used in the Redis serialization protocol? What character isn't used here? So can I change the default delimiter from /r/n for scanner to /r/n/r/n/r/n/n. I'm assuming there won't be four return carriages with new lines, one after the another. So I'll change it to that. If my code breaks in future, I'll increase the /r/ in the delimiter. Why am I increasing in the delimiter? Because I want to read everything in the input stream and not just line by line. Okay, scanner.use delimiter. So if I print everything here, let's see what I get here. I'll abuse the blunt code. That's what I paid for. I paid for the whole Codecrafters. I'll use the whole Codecrafters. Huh, didn't work. I was expecting to read everything. All this should be in one line. Why did the delimiter not work? Scanner, where is the scanner? sc.use delimiter /r/n. How about dot next? I'll read everything. I think next method reads everything. I think next method reads everything. I'm not sure. I don't remember. Used to use scanner and bruh. कुछ तो राइट कर देता. I think I don't need to change the delimiter. So if I use next line, it will by default break on /r/n. If I use next, it will only break, but it was never found. I'm assuming that's the issue. If this doesn't work, I'll convert my code to use bytes instead. I'll do that in the next video. I'll manipulate the raw bytes in the next video. So right now you can pass the initial stages with a scanner class. Perhaps you can go much ahead. Ah, you can't. It's an array. It has three elements. It has three elements. I can. Should I read the raw bytes as of now? I don't think so. I can use this data. Yeah. Hmm. Okay. So why I'm stumped is because initially I had done this challenge by manipulating the raw bytes. Now I'm trying something new. I'm trying to use the scanner class. Why didn't I think of using scanner before? I don't know. God only knows. So how using the okay, I'll do that in the next video. That's it for this video. Let's see you I'll see you in the next one.